You're staring at it right now, aren't you?
Oh, we all know that look.
Right. That messy, totally overwhelming stack of family history you swore you were going to organize. Faded letters in a shoebox, confusing census data that barely even looks like English.
Maybe a handful of untranslated records from, like, the old country.
Exactly. And for anyone digging into their genealogy, it usually starts with this exact chaotic pile. And you might be sitting there thinking, I'll just throw all of this into artificial intelligence and it'll sort it out instantly.
Which is such a tempting thought. I mean, we all want that magic button.
We really do.
Yeah.
But bringing AI into historical research, well, it's a bit like jumping out of a horse-drawn carriage and straight into a high-performance sports car.
That is a great way to put it.
It's thrilling, and it will get you to your destination incredibly fast. But if you don't know how to steer, you are going to crash and take your family's actual historical facts right down with you.
And that right there is the paradox of modern research. You have all these distinct pieces of a puzzle, but no picture on the box to actually guide you.
Right.
So when we look at the insights from Lori Coffey, she's a computer trainer and a Genealogy Society president, her overarching mission for us today is clear. We have to demystify what this tool actually is before we just hand over our heritage to it.
We need to understand the AI mindset.
Exactly. We have to know how it thinks.
Which means we need to talk about large language models or LLMs, things like ChatGPT or Google's Gemini, because there is this massive misconception out there right now.
Oh, huge. People treat these systems like they're a magical oracle.
Yes. They think they can just sit down, type in, who was my great-great-grandfather, and the AI will just, go out into the ether, do the research, and hand them a perfectly completed family tree.
And relying on AI to discover facts you don't already know is just a recipe for disaster.
Why is that?
Yeah.
Exactly.
Well, to understand why, we have to look at the mechanics of an LLM. At its core, a large language model is not a search engine pulling up verified documents.
Yeah, they're not Googling things for you.
No, not at all. It is essentially the predictive text feature on your smartphone, just scaled up to an unimaginably massive level. It doesn't actually know facts.
It just guesses what comes next.
Pretty much. It calculates the statistical probability that one word should follow another, and it does this based on the billions of texts it was trained on.
That perfectly sets up how Lori Coffey personifies her AI in this deep dive. To make this, less abstract, she calls her AI Robbie.
Robbie the intern. I love this analogy.
It's so good. So imagine you've just hired this incredibly eager college intern. Now, Robbie has an estimated genius-level IQ of about 160.
He's brilliant.
Insanely smart. In just 6 months, he has literally absorbed millions of books, textbooks, historical documents. He's basically swallowed the entire internet.
But there's a catch with Robbie.
Always a catch.
Robbie is a complete sycophant. He is a pathological people pleaser.
Oh, interesting. So he just wants to make you happy.
Exactly. Because his entire programming is designed to provide you with an output. He wants to please you so badly that if you ask him a question he doesn't know the answer to, he won't simply admit he doesn't know.
He won't just say, I have no idea.
Nope. His predictive text engine will just stitch together plausible-sounding words and confidently invent an answer for you. And in data science, these fabrications are known as hallucinations.
Okay, wait, I have to push back here. If Robbie has an IQ of a 160 and literally contains the knowledge of the entire internet, why do we have to baby him so much? Why is he so prone to just making things up?
Well, the distinction lies between raw pattern matching and actual lived experience.
Okay, what do you mean by that?
So AI possesses massive computing power, right?
Right.
But it has absolutely zero human context.
Yeah.
It lacks the nuanced critical thinking that a human researcher develops through trial and error over years.
Right, it's never actually lived a human life.
Exactly. Consider a classic historical research scenario. Say you are looking through 1850 census records, and you find two different men named James Smith living in the exact same county.
Ugh, a total nightmare for anyone building a family tree. Just the worst.
Oh, absolutely. But for a human, we know how to navigate it. We look at the surrounding context, like who are their neighbors, what are their occupations, who are they married to?
Right, you look for the clues.
We understand inherently that a single person cannot be a wealthy merchant living in town and an impoverished blacksmith living on a farm at the exact same time.
Because that physically defies reality.
Right. But Robbie, however, just sees the matching name James Smith and the same county. Without the guardrails of common sense, his probabilistic engine might just smash those two distinct lives together into one impossible superperson.
Oh, wow. So Robbie is brilliant, but he possesses absolutely zero common sense.
None at all.
That explains why we can never ask him to research a blank space in our family tree. His primary role is entirely different. AI is for analyzing information you already have.
Yes. You have to bring the facts to the table.
We have to feed him our structured data and guide him, which actually kind of mirrors the broader journey of how humans process information in the first place.
It really does. Information science uses this framework called the DIKW model that stands for data, information, knowledge, and wisdom.
Okay, BIKW.
And genealogy is essentially the physical manifestation of this exact model. Coffee points to the Doomsday Book from the year 1086.
Wait, the one commissioned by King William the Conqueror.
That's the one. It was essentially England's first census.
Right. And in its raw form, that massive ledger is just data. I mean, it's an endless list of names, properties, livestock.
Just a wall of text.
Exactly. To a modern researcher, it is completely overwhelming and practically useless until it gets organized. But the moment you can query it, the moment you can ask, where did the Smith family live, and get a specific list of locations, that raw data transforms into information.
Right. It becomes useful. And as you gather more of those specific answers, that information synthesizes into knowledge about your specific ancestors.
It builds on itself.
Yep. And finally, when you take that knowledge and use it to draw broader conclusions, like, say, recognizing that your ancestors migrated out of a specific county precisely when a famine hit, and you write that context into your family narrative, that final stage is wisdom?
That's the holy grail of family history right there.
It is. And AI acts as a massive accelerator for this exact process, but it requires human guidance to make that leap from data to wisdom.
So let's look at how that human guidance actually works in practice, because there's a great example of the deep dive using the massive 2022 release of the 1950 U.S. Census.
Oh, this is a fascinating case study.
When those millions of handwritten census pages were released by the government, a genealogy company scanned them and used an AI program called Textract to create the initial searchable index.
Right, but they attempted to use traditional OCR first, right? Optical character recognition.
Yeah, and the problem with traditional OCR is that it was designed to recognize rigid, perfect typewritten letters.
Like printed books.
Exactly. When you feed it messy, flowing 1950s cursive handwriting, the system just completely breaks down. It cannot understand the context of a continuous ink stroke. So the initial index was filled with catastrophic errors.
Just garbage text everywhere.
Pretty much. So to fix it, FamilySearch.org invited volunteers to help. And 200,000 volunteers logged on and painstakingly corrected the computer's mistakes.
Which is incredible on its own.
It is. But here is the mechanism that makes this so revolutionary. By fixing those mistakes, the volunteers weren't just editing a static database. They were actually feeding the corrected text back into the neural network.
They were updating the mathematical weights of the algorithm in real time.
Wait, really? Just by fixing typos?
Exactly. When a volunteer corrected, say, a bizarrely looped cursive S that the machine originally thought was an L, the machine learned the spatial relationship of that specific stroke.
Oh, so it learned the handwriting style.
Yes. The next time it encountered that same loop, it recognized it correctly. This crowdsourced feedback loop is the backbone of generative AI today. And because of that human interaction, what would have normally taken 5 years to index was completed in just 6 months.
5 years down to 6 months.
Yeah.
That is wild. It fundamentally changes the relationship we have with our tools.
Right.
Like old school OCR is like a stubborn spell checker that just underlines your mistake in red over and over, but never actually learns anything.
Right. It just keeps telling you you're wrong.
Exactly. But modern AI is like a student who watches you correct the spelling, internalizes the underlying grammar rule, and applies it perfectly the next time.
Which means the output is entirely dependent on the quality of your instruction. If the AI is the learning student, the researcher has to become a highly effective teacher. Or, in Coffee's terms, a better AI boss.
A better boss to Robbie the intern.
Precisely. You cannot just type a casual, unstructured sentence into a chat box and expect Robbie to hand you genealogical gold.
You have to use what's called prompt engineering. And Coffee breaks this down into an essential 4-part formula. It's role, task, format, and restrictions.
Let's dig into that first one, role, because establishing the point of view is the step people miss the most.
Yeah, you literally have to tell Robbie who to be.
Yes, and assigning a role fundamentally alters the AI's internal math.
How so?
Well, when you give it a prompt without a role, it draws on every single word in its massive database equally. It has no focus. But if you start your prompt with, act as an expert genealogist and an experienced writer, you instantly narrow down the universe of words Robbie will choose from.
Oh, you constrain the vocabulary.
Exactly. You constrain the vector space to vocabulary appropriate for a historian. That eliminates modern slang or inappropriate tones before the AI even begins processing the task.
That makes so much sense. So after you narrow the vocabulary by giving him a role, you give him the task, like transform these census records into a 300-word biography.
Right. And next is format. You need to set a specific tone, serious, witty, scholarly.
And didn't Coffee also strongly advise setting a reading level? Like telling Robbie to write at a 10th grade reading level.
Yes, that is such a pro tip. Setting the reading level prevents the AI from defaulting to dense, overwhelming academic jargon. Remember, Robbie has a 160 IQ.
Right, he's a genius.
Left to his own devices, he will write a doctoral thesis that is just a complete chore to read.
Okay, let me ask a practical question to see what happens when we break these rules. If I ignore this formula and I just paste in my grandfather's birth and death dates, maybe a couple of locations, and I just type the prompt, write a story, what does the AI actually do?
Oh boy, if you don't restrict the format and the tone, the AI just searches its database for the statistical structure of stories. Coffee actually shared a specific, real-world example of this exact mistake.
What happened?
Because the prompt just asked for a story, the AI literally started her ancestor's biography with the phrase, "once upon a time."
Oh, wow. It turned her actual grandfather into a literal fairy tale.
Because it didn't know any better. To the AI, a story equals a fairy tale structure. This is why the fourth part of the formula, restrictions, is totally non-negotiable.
You have to be specific.
You must explicitly command the AI. Only use the provided text. Do not invent details. Maintain a serious tone.
So you have to explicitly ban hallucinations.
Yes.
And on top of those restrictions, there are two behavioral quirks to keep in mind when managing your AI intern. First, and this is kind of funny, say please.
It sounds so absurd to use manners with computer code, doesn't it?
It really does. But the data shows that using polite framing, actually saying please, yields more compliant and helpful results.
That's because LLMs are trained on human conversation. In the datasets they analyzed, polite language usually frames a cooperative, highly constructive exchange. So by being polite, you trigger the mathematical pathways associated with helpfulness.
That is fascinating. The second quirk is using reinforcement learning. Like, if Robbie gets the tone wrong or misses a detail in the first try, you don't just quit and walk away frustrated.
No, you treat it like an ongoing conversation. You tweak the prompt, you tell him, that was a good start, but please rewrite it without using the word story.
So you're iterating.
Exactly. You are refining the AI's focus step by step. And once you master this conversational control, you can step out of the generic chat boxes and start applying these skills to dedicated genealogy software.
Right, because the tools currently transforming the field operate on these exact same principles, but they are hyper-focused on our specific bottlenecks.
Whoa, true.
So let's open up that genealogy AI toolkit, starting with translation and transcription. Let's say you have a stack of old family letters from Germany or an ancestor's birth certificate in French. Google Translate is fine for a typed menu at a restaurant, but if you're dealing with fancy, completely illegible old German script from the 1800s.
Oh, Google Translate is going to fail completely.
Yeah.
Standard translation apps are just looking up words. They can't parse handwriting. But there is a specialized AI tool called Transcribus. That's spelled with a K.
Transcribus, okay.
And it uses dedicated neural networks trained exclusively on historical handwriting. Instead of looking for rigid, separate letters, it analyzes the entire word as a single image. It uses the context of the strokes around it to decipher whether a massive loop of ink is a G, a Y, or just a flourish from the pen.
And MyHeritage has built a similar feature directly into their platform called Scribe AI. Coffee used it on Civil War disability papers.
And 19th century military and medical handwriting is notorious.
Oh, it's terrible. It's faded, it's cramped. It often looks like a doctor's prescription that was left out in the rain.
For an untrained researcher, deciphering a single paragraph of that text can take an hour. But Scribe AI reads the fluid shapes, cross-references them against its training on millions of similar military documents, and transcribes it instantly.
And you can pull the legible text right into your notes.
Exactly.
That alone is incredible. But moving beyond transcription, we have summarization. And this is arguably the most powerful day-to-day application. There's a Google tool called Notebook LM.
Oh, Notebook LM is a game changer.
Coffee used it to tackle a 276-page PDF. It was a raw verbal transcript. There was no punctuation, no paragraph breaks, just a massive, uninterrupted wall of text.
Slogging through 276 pages of unpunctuated text, that would consume weeks of a human researcher's time just trying to find the basic chronology of events.
But she uploaded that massive file to Notebook LM, and instantly the AI parsed the grammar, added all the necessary punctuation, extracted the key dates, and generated a neat 2.5-page chronological timeline.
2.5 pages from 276.
Yes. It condensed all that rambling noise into the exact narrative she needed to continue her research.
And the defining feature of Notebook LM is its architecture. When you upload your documents, it creates a closed system.
What does that mean, a closed system?
It essentially walls itself off from the wider internet and only analyzes the text you provided. This drastically reduces the probability of hallucinations.
Oh, because Robbie isn't allowed to go searching the web to invent an answer.
Exactly. He is locked in a room with only your documents.
But sometimes you absolutely need to search the wider world. And that brings us to deep searching. Specifically, Family Search's new full-text tool.
This one is huge.
To understand why this is such a monumental leap forward, we really have to look at how searching used to work. Historically, you could only find an ancestor in a database if a human being had formally indexed that record.
Meaning someone manually read the document and typed your ancestor's name into a search field.
Right, and while indexing is vital, Family Search holds 10 billion records.
The sheer volume makes it yes. If your great-grandfather was just a bystander or a witness who happened to sign the bottom of his neighbor's land deed, his name was never indexed. But this AI can read the handwriting of the entire deed and flag his name buried in the final paragraph.
The best way to visualize this is to imagine a library with 1 million locked diaries. In the old days, you had to wait for a human to find the key to each diary, open it, read every page, and write down the names they found.
A painfully slow process.
Very. But the full-text tool essentially x-rays all 1 million diaries simultaneously, reads the cursive right through the covers, and instantly highlights that your grandfather's name is on page 42 of diary number 800,000.
That visual perfectly captures the scale of the technology. And studies analyzing the impact of these specific tools show that researchers are, on average, 29% faster when using AI for searching, transcribing, and summarizing.
Almost 30% faster.
Yeah. It eliminates the grueling, eye-straining hours of raw data processing. It frees up the researcher's mental load, allowing them to actually focus on making historical connections and synthesizing the wisdom of their family's story.
It is undeniable how revolutionary these capabilities are. But as amazing as it is that AI can x-ray 1 million records in seconds, that exact same processing power is what makes it so incredibly dangerous if it isn't handled with extreme care.
Oh, absolutely. We need to talk about the guardrails.
Yes, the guardrails.
The sheer speed of AI synthesis means that if a mistake is introduced, it compounds rapidly. And the very first completely non-negotiable rule of using AI in genealogy concerns privacy.
Right.
You must never, ever input information about living people into a public AI chatbot.
Because when you feed data into a system like ChatGPT, you are handing that data over to a corporation. And while they claim specific prompts are anonymized, human reviewers often have access to that text to refine the system.
And let's be honest, corporate data breaches are an everyday reality.
Exactly.
Yes.
You are risking the exposure of your living relatives' names, birth dates, and locations on a server that could easily be compromised.
So if you intend to use AI to draft a sensitive family history that involves living people, you must anonymize the data first. Change the names, change the locations, and only use the AI to structure the narrative template.
Beyond data privacy, there is the literal dark side of generative AI, where malicious actors use these tools to manufacture reality. Lori Coffey highlighted a genuinely chilling example of this.
It really was.
Following a series of severe hurricanes, scammers utilized AI to generate incredibly realistic fake images, fake videos, and synthesized audio depicting massive catastrophic flooding in Gatlinburg, Tennessee.
And they deployed these deepfakes across social media to solicit disaster relief donations for a flood that never actually occurred.
The barrier to creating highly convincing fraudulent media has essentially dropped to zero.
It's terrifying.
It really gives me a massive amount of anxiety regarding our own research. Like, if AI can fabricate a whole natural disaster out of thin air, if it can generate a hyper-realistic photo of a flood that didn't happen, how can we ever trust the historical records, the faded photos, or the stories we find online moving forward?
That anxiety is entirely justified, and it demands a fundamental shift in how we approach research. Skepticism must become your default setting.
We have to question everything.
Coffee anchors this mindset by quoting Thomas Jones, a renowned genealogist who operates by a simple rule: consider everything, trust nothing.
Consider everything, trust nothing. I like that.
Right. AI is a brilliant tool for synthesizing information, but human verification remains the ultimate gatekeeper of historical truth. You must trace every AI-generated lead back to its original physical source.
And maintaining that truth requires us to adopt strict ethical rules for our own work, specifically regarding citation.
Yes, citations are crucial here.
Let's say you use an AI tool to fix a blurry, damaged tintype photograph of your great-grandmother. The AI software removes the scratches, sharpens her face, and adds lifelike color. You absolutely must tag that resulting photo in your family tree as an AI-enhanced image.
This is a critical point for long-term genealogical integrity. When AI enhances a bleary photograph, it is not magically revealing what was hidden beneath the blur.
Right, it's not a magical magnifying glass.
No, it is making educated mathematical guesses. It is predicting what those facial features probably looked like based on its training data of millions of other faces.
So if you don't clearly label it as AI-generated, a researcher 50 years from now might look at that beautifully sharpened photo and firmly believe they share specific cheekbones or eye shapes with their ancestor.
When in reality, they just share cheekbones with an AI's mathematical algorithm.
That is such a trippy thought. We are essentially tasked with protecting the historical record for generations of researchers who haven't even been born yet.
And while we are considering the broader impacts, we also have to acknowledge the physical infrastructure of AI. These massive data centers require staggering amounts of energy and water to cool the servers processing our prompts.
Right. So as Coffee advises, utilize the technology for meaningful research, but recognize the environmental footprint and don't just waste the processing power on trivialities.
Be intentional with it.
Exactly. We've covered a tremendous amount of ground today. We've seen how AI functions as this brilliant, slightly quirky intern named Robbie.
The 160 IQ people pleaser.
That's the one. We know he can transcribe 19th century German script using neural networks, and he can summarize a 200-page unpunctuated PDF into a clean timeline in mere seconds.
But extracting those genius-level results requires you to be an exacting boss. You have to craft clear prompts with specific roles and tight restrictions. You must bring your own verified facts to the table.
And above all, you have to double-check everything to ensure your intern hasn't hallucinated a fairy tale.
No once upon a time's allowed.
Right. You take that messy stack of faded letters, and you use this incredible sports car of a technology to help you navigate the journey. But you never let go of the steering wheel.
Never.
Which leaves us with something I want you to consider as you dive back into your own archives. As these neural networks continue to evolve at breakneck speed, it's not hard to imagine a near future where you log on to a genealogy site, click a single Create My Family Tree button, and the AI instantly x-rays billions of records, translates them all, and hands you a perfectly formatted 500-page book of your entire family history.
Zero effort required on your part.
Exactly.
Yeah.
But if an AI hands us our fully written history instantly, do we lose the joy of the hunt? Does knowing exactly where we come from mean as much if we didn't have to sit with that messy stack of papers, squint at the faded ink, and struggle to uncover it ourselves?